Hey guys, I'm back to talk to you about seasons. That's right, football season. Oh, not supposed to talk about football season. The seasonal climate. Gotcha. All right, we're here to talk about the 4 seasons that are brought on by our Earth and the tilt that we have in our globe. So our Earth is tilted at 23.5 degrees, which doesn't seem like a whole lot, but it greatly affects our climate and the weather patterns that we have. The tilt causes certain parts of the Earth to get more sun rays than other parts at certain times of the year. And so I want you to take a look at this video to help explain a little bit more about why that causes us to have distinct and different seasons throughout certain parts of the year.
You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these 2 seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
So as we better understand how Earth's tilt affects our seasons, a couple other terms you need to know. First one is solstice. Solstice is a day on which the sun's rays shine directly over the Tropic of Cancer in the northern hemisphere, and the Tropic of Capricorn down in the southern hemisphere. So the summer solstice is the longest day of the year for us in the northern hemisphere. Happens somewhere around June 21st, June 22nd. In the winter solstice, it is the shortest day of the year. The sun's rays are actually directly over the Tropic of Capricorn in the southern hemisphere. And so for us, it is our shortest day of the year, somewhere around December 22nd, 23rd. And then we also need to know equinox. That's a second one. Equinox happens when the days and nights are exactly equal. So equal is equinox. And this marks the start of spring and autumn. March 21st is our date that starts spring. September 23rd is the start of autumn, and the days and nights are exactly equal. So once we get past those days either begin getting longer or they are shorter. Now, it's also important for us to understand the difference between weather and climate, because they're not the same thing, although sometimes they tend to merge in what we describe them. But when we look at weather, it's the condition of the atmosphere at a particular time. And so we are looking at a short span of time and what is going on in that particular region on a given day. When we're looking at climate, we are looking at the condition over a long period of time, something that happens over and over that we can count on. So there are a number of causes to why we have different climates or different weather. And you can see those up on the screen. But water vapor determines if we are going to have precipitation or not. And that precipitation can come in a number of different ways. It can come in rain, snow, sleet, or hail, or a mixture of all of those things. The cloud cover could hold the water vapor, or usually does, and that cloud cover is dependent upon how much water vapor is in the atmosphere at that particular moment. And we may also see landforms and bodies of water affect how much water vapor is up in the air. Elevation could also affect that, and air movement. And we'll talk about that a little bit later on. So precipitation depends on how much water vapor is in the air. So as warm air rises and cools, it loses the ability to hold water vapor. And so then water condenses to form clouds. And we look up in the sky, we see clouds forming all over the top in the atmosphere, and we often try to figure out, that one looks like a puppy. That one looks like a balloon. That one looks like, I have no idea what that one looks like. But we're trying to figure out what they look like, but yet all they are is water vapor floating up there in the atmosphere. And so as warm air rises and it starts to cool, now it's going to lose the ability to hold the water vapor, and the water vapor is eventually going to begin to condensate and fall down to the earth as the clouds get too heavy. There are a couple of different types of precipitation. First of all, we have convectional precipitation. That is usually found in a hot climate. So in the morning, as the sun comes out, it warms the air. And the moisture and the heat and that works together in the air warms up, and it forms water vapor, and then that water vapor rises and it forms a cloud. And the clouds get up in the atmosphere, they get really dense, very heavy, and usually in the afternoon, they begin to let off rain. It happens quite often down in the south in the hotter atmosphere. So we also have orographic, and that's typically found in a mountainous region. And so what will happen is as the clouds approach the mountain, they get about here, and as the moisture is blocked by the mountain, they can't go anywhere except for up. So as it starts to go up and the water starts to cool off and becomes very heavy in the atmosphere, now it is forced to rain or snow on this side of the mountain. We call this side of the mountain the windward side. And so it lets off the precipitation, the windward side. The clouds continue to rise as they get lighter, and they move up over top of the mountain. We get to the back side of the mountain over here, as those clouds have now given off all their precipitation over here on the windward side. They are now moving to the other side, and they have no water vapor left, or very little. And so the back side of the mountain gets very little rain or snow, and we call that a rain shadow. And this is the leeward side of the mountain, and oftentimes you'll find a rain shadow over here. So this side gets lots of moisture on the windward side. On the leeward side, on the back side of the mountain, not a whole lot. So if you're wanting to plan a ski trip, go to this side of the mountain. Don't go to this side of the mountain. Now, the third type of precipitation is frontal. This is created between two air masses that have different temperatures. And as they meet one another, one of them is going to have to rise and one of them is going to have to fall. Typically, we're going to see the warmer air rise up and the cooler air stay below. And as that warmer air rises up, it becomes very dense, very heavy, and eventually it is going to have to fall out of the atmosphere in the form of precipitation. So that is a frontal. We get a lot of those around here, where we have two major fronts getting ready to meet one another. One rises, one falls, and we're going to see some precipitation. Now, it's important to also understand weather extremes. Several different types of extreme forms of weather that you'll see weather people all over TV talking about. Now, it's also important for us to understand weather extremes because these can often occur in different types of climate depending upon where we live. So, the first one is a hurricane. Not cool. These are storms that form over warm tropical ocean waters and can be very, very intense. And these can cause extreme amounts of damage. And so, if you hear of a hurricane coming, you better watch out. And you're not going to want to take that lightly. In the center of a hurricane is something called the eye. This is a really strange phenomenon where you have gone through hundreds of miles an hour of wind in the outer part of the hurricane, and then all of a sudden you get to a clearing, and you can have 10 to 20 miles in this eye where it is totally blue skies, there's no wind, there's no rain, everything seems calm, you think that there's nothing going on, and then all of a sudden, boom, it hits you once again with the other half of this hurricane. So you've got to watch out for that. Now, the second type is a tornado. These are very powerful funnel-shaped columns of spiraling air, and these can appear very quickly, almost like my football here that's spiraling out of control. So we have a tornado that can appear very quickly in the sky. We see a lot of these in the Midwest. There is a tornado scale that helps us rate the intensity of these tornadoes. It's called the Fujita-Pearson scale, and it rates tornadoes anywhere from F0, which really don't do a whole lot of damage at F0, all the way up to F5, which are the most intense and extreme sort of tornadoes that you can have. Those are very deadly. You've got to watch out for those. But anytime there's a tornado, you've got to make sure that you head to some sort of protection. Don't take those warnings lightly. And any tornado, no matter what the scale, could cause some sort of damage. Now, droughts are also a weather extreme. It's where you go long periods of time without rain, or sometimes just minimal rainfall when you're accustomed to getting a lot more. Often this will affect agriculture. It could also affect the industry depending upon the area in which the drought occurs. So rain is very important to most parts of the globe, and droughts can affect how people live. Floods are the opposite extreme, where you have too much water, and it's where you have water that spreads over land that's not normally covered by water. And again, you have to watch out for these. Don't take these lightly. Have flood insurance if you are in a flood zone, because floods will cause a lot of damage, and they can happen very quickly without you even realizing that they're coming. And so make sure that you pay attention to each one of these areas we've talked about today, and come ask questions if there's something you don't quite get or don't understand. We'll talk to you later.